Hello students, welcome to Success Classes. This is Shweta Agarwal. Today we will study chapter 1 of class 10 science, that is chemical reactions and equations. So let's get started. Now let us first have a quick look on the topics that we have to study in this chapter. The first topic is chemical and physical changes. The second is the chemical reaction. We will study about the chemical reaction with the help of few activities. Then we will study about the exothermic and endothermic reactions. Then we will see the few observations that takes place during a chemical change. Then we will study about the chemical equation and the balancing equations and how can we more a chemical equation more informative. Then we will study the very important topic, that is the types of chemical reactions. The various types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction reactions. And then we will study about the corrosion and rancidity. So, let's start the topic one by one. There are the two types of changes that occur in our daily life: the physical change and the chemical change. The physical change involves the changes in the physical properties of the substance or the matter. During a physical change, no new substance is formed. The identity of a substance is not changed. And the third one is the physical change is a temporary change. The few examples for a physical change are the melting of ice, boiling of water, condensation, tearing of paper, etc. Now in the figure you can see that the solid, liquid, gas are the three states of matter that we have already studied in our class 9th. And water exists in all the three states, that is the solid, liquid and gas, and all these states are interconvertible. Now we will come on the chemical change. The chemical change is a change which involves a change in the chemical properties of the substance. Here, the nature and identity of the substance is changed. Old bonds break and the new bonds are formed. The reactants are converted into substance due to the formation or broken down of older bonds. So, during a chemical change, the reactants undergo broken down bonds, and due to these broken down bonds, the new bonds are formed and the new substance with new identity is formed. Atoms in the reactants are rearranged to form one or more products of different properties. The chemical change involves a chemical reaction. So whenever there is a chemical change, a chemical reaction occurs. And the chemical change is a permanent change. For example, digestion of food, burning of candle, cooking, rusting of iron, burning of magnesium ribbon. Now, here is a diagram for the burning candle. So, can you say that the burning of candle is a physical change or a chemical change? Burning of candle involves both the changes, the physical change and the chemical change. Here, melting of wax involves a physical change and the burning of wick involves the chemical change. Now, let us understand few activities to understand the chemical reactions. The first activity is burning of magnesium ribbon in air. So you can see the magnesium. Here is the magnesium ribbon. It is silvery white in color. So take a small piece of the magnesium ribbon and clean it with the sandpaper. Now the question arises, why we have to clean the magnesium ribbon with the sandpaper before burning? So magnesium ribbon is cleaned before burning to remove the magnesium oxide and dirt from its surface. It forms when magnesium ribbon is exposed to moist air. This layer obstructs burning of magnesium. See, magnesium is a very reactive metal. So when it is kept exposed, जब उसको हम ऐसे ही छोड़ देंगे तो वो जो रिएक्टिव मेटल है वो एटमॉस्फेयर के मॉइस्चर एंड ऑक्सीजन से रिएक्ट करके एक मैग्नीशियम ऑक्साइड की लेयर बना लेता है. एंड अगर वो लेयर को हम रब करके उसको क्लीन नहीं करेंगे तो फर्दर बर्निंग हिंड्रेंस होगी. सो इसलिए पहले मैग्नीशियम रिबन को सैंड पेपर से क्लीन किया जाता है एंड देन वो जब अंदर का क्लियर मेटल बाहर आ जाता है तब उसको बर्न किया जाता है. सो टेक अ पीस ऑफ मैग्नीशियम रिबन, होल्ड इट विद द टोंग्स and then burn it in the flame of Bunsen burner. And we will see the ashes coming out because the chemical reaction takes place and magnesium burns in ashes. And the color of the ash is white powder. We will see white powder which we collect in the china dish. So here you can see in the figure you can see this. So we have to take a precaution that magnesium burns. When the magnesium burns, we have to keep it away from our eyes as far as possible because magnesium burns with a dazzling white flame and that is very that flame is harmful for the eyes. So what we observe in this experiment that on burning in air, magnesium ribbon gives a dazzling white flame and changes into a white powder of magnesium oxide. So the reaction here is twice Mg that is solid plus oxygen that is gaseous will give twice MgO that is solid. So in this video you can see the magnesium burns with a dazzling white flame. Now the second activity is reaction of lead nitrate and potassium iodide. When lead nitrate is mixed with potassium iodide, a precipitation reaction occurs and the yellow precipitate of lead iodide is formed. So here you can see that the lead nitrate and potassium iodide both are colorless. But when they are mixed together, they form a yellow precipitate of lead iodide. So here is the reaction. PbNO3 whole twice plus twice Ki will give PbI2 plus twice KNO3. So this you can easily see in the given video. Wow. Now third activity is action of dilute sulfuric acid on zinc. It is the property of metals. See, zinc is a metal and it is a property of metals when they react with acids, or we can say dilute acid, hydrogen gas is liberated. So this is seen in this experiment. Zinc reacts with dilute sulfuric acid to produce hydrogen gas and zinc sulfate. This reaction is also called displacement reaction that we study in the further videos. So in the video you can see that we have taken sulfuric acid and in the sulfuric acid we have put few zinc granules and we can see the bubbles clearly here. So these bubbles show that gas is evolved. But how can we say that the gas evolved is hydrogen gas? So for this we have a test for hydrogen gas. When a lighted candle is brought near the mouth of the test tube containing hydrogen gas, it burns with a pop sound. So here you can see the test tube containing the solution in which the hydrogen gas is evolved. So when the burning candle, a lighted candle is brought near the mouth of the test tube containing hydrogen gas, it burns with a pop sound. So I hope all the three activities are clear to you. Now on moving further, we will study about the exothermic and endothermic reactions. So endothermic reaction and exothermic reactions are the reactions where heat is either produced or heat is absorbed during the reaction. So first look about exothermic reaction. Exothermic reaction is a chemical reaction which is accompanied by evolution or formation of heat. So all those reactions which occur by the evolution of heat are called exothermic reactions. And one of the example is the respiration. Here glucose in presence of oxygen, glucose is break down in the presence of oxygen to form carbon dioxide, water and energy. So as we have seen liberation of energy is here, so it is a exothermic reaction. Endothermic reaction is a chemical reaction which involves absorption of heat. So during photosynthesis, carbon dioxide and water in presence of sunlight and chlorophyll, they form sugars, water and oxygen. So as we have seen that during photosynthesis, sunlight is absorbed. So it is a example of endothermic reaction. So now it is clear that a chemical reaction is the process by which two or more substances react with each other to form new substance with different properties. Now the compounds which take part in the reaction are called reactants, and the compounds which are formed during the reaction are called products. And the reactant may be one or more and the product may also be one or more. Now there are few observations that takes place during a chemical change. The first is the change in the state of the substance, that is the state from solid state to liquid state or liquid state to gaseous state, etc. Second is the change in the color of the substance. The change in the color of the substance. We have seen that there are few experiments where the color of the reactant changes. So with the help of color we can say that the chemical reaction have taken place. Now third is the change in the temperature. So there may be the change in the temperature. While performing experiment we can see that the test tube or the beaker may become hot. So there may be change in temperature takes place. The next is the evolution of heat and the absorption of heat that we have seen already in the endothermic and exothermic reactions. Next is the evolution of gas that we have just seen in our activity 3, evolution of hydrogen gas. So there may be evolution of any gas, maybe carbon dioxide, maybe oxygen, etc. And the last one is evolution of light and sound. So these are the few observations that tell us that a chemical reaction or a chemical change has taken place. Now what a chemical equation is? Now we have seen a chemical change, we have seen a chemical reaction. The chemical equation is the technique of writing a chemical reaction. अब केमिकल रिएक्शन तो हो गया बट उसको हम ऑन पेपर कैसे शो करेंगे? सो it is the symbolic representation of the chemical reaction. On papers, we will show a chemical reaction by the chemical equation. So the general chemical equation is A plus B will give C plus D. So here you can see that the reactants, we have put the plus sign between the reactants and the plus sign in between the products. And we have put an arrow which shows the direction of the chemical reaction, and the direction of reaction is forward direction. So the A and B are the reactants and C and D are the products. For example, magnesium plus oxygen will give magnesium oxide. So this is the word equation. So we can write the chemical equation in words also and with the help of the symbols also. But generally we use the symbols because writing the equation in words may be lengthy. So where 2 or 3 reactants or products are involved. So we generally use the symbols or the formulas for the compounds. So the chemical reaction is of two types. It may be unbalanced chemical equation or it may be balanced chemical equation. The chemical equation is of two types. The unbalanced chemical equation is also called the skeletal equation. Here the symbols and formulas are simply representing. For example, Mg plus oxygen O2 will give MgO. So it simply represents the symbols and formulas of the reactants on the products taking part in the reaction. Here, the mass of reactants is not equal to the mass of products. That is, it does not satisfy law of conservation of mass. But the balanced chemical equation, a chemical equation having equal number of atoms on both the sides of the reaction. So, the balanced chemical equation obeys the law of conservation of mass. So, here you can see zinc plus H2SO4 will give ZnSO4 plus H2. It is balanced chemical equation. And second is twice Mg plus O2 will give twice MgO. So it is also a balanced chemical equation. The mass of reactants is equal to mass of product. Now the question comes that why should a chemical reaction always be balanced? A chemical reaction should always be balanced to satisfy the law of conservation of mass. That is, total mass of reactant should be equal to the total mass of products. So here we can see the example that Fe plus H2O give Fe3O4 plus hydrogen. It is not a balanced equation. Fe contains 3 atoms, but here Fe contains 1 atom. So the balanced equation for this is 3Fe plus 4H2O will give Fe3O4 plus 4H2. So balancing the chemical equation we will study in the next video. To make the equation more informative, we should mention few things like the physical states of the reactants or the products. That is, whether the reactants or the products are in gaseous form, liquid form, aqueous form or in solid form. Aqueous means that there is the solution of the reactant or product in water. The second condition is the reaction condition, that is temperature, pressure, catalyst, etc. And these reaction conditions are always written on the above or below the arrow because they do not directly take part in the reaction. So they are written above or below the arrow. For example, 6 carbon dioxide which is in aqueous form plus 12 H2O which is in liquid form in presence of sunlight and chlorophyll form glucose C6H12O6 in aqueous form plus 6O2 in aqueous plus 6H2O in liquid form. Because these all are absorbed by the plants, so they are in aqueous or liquid form. Next is carbon monoxide, that is in gaseous form, plus hydrogen in gaseous form in presence of 340 atmospheric pressure. It will form methyl alcohol in liquid form. So I hope this video is clear to you. The next topics we will continue in our next videos. So thanks for watching, and if you like my video then please like, share and subscribe the channel. Till then, stay happy and safe. Thank you.